Okay, so in this video, we're going to look at matrix multiplication in the most general case. So in a previous video, we looked at multiplication of 2 by 2 matrices, and I'll put a link to that on the screen and in the description. But in this video, we're going to look at multiplication of general m by n and n by k matrices. So what's the setup for the problem? Firstly, we take a matrix A, which is m by n, so this just means m rows and n columns. And we take a matrix B, which is n by k, which just means n rows and k columns. And we want to ask, what is the product AB? So before we try and answer this question, we're going to write down A and B explicitly using some notation. So we're going to write the first entry as A11, which just means that it's in the first row and the first column. The second entry will be A12, which just means row 1, column 2. And we're going to go all the way down to the top right entry, which we'll write as A1n, which just means row 1, column n. And we'll do the same going down. So here we have A21, which means row 2, column 1. And if we go down to the bottom left entry, we have AM1, which means row m, column 1. And filling in the matrix, we would have here, say, A22, row 2, column 2, and all the way down to the bottom right, we would have AMN, which just means row M, column N. We're going to do something similar for B, so if we write B8, the top left entry will be B11, the next entry will be B12, and the top right entry will be B1K, so the first row and the kth column. Going down, we would have B21 all the way down to BN1. Here, for example, B22. And if you fill in all the gaps, down to the bottom right entry, you have BNK. So if we just emphasize for a moment the size of these matrices, A has m rows and n columns, and B has n rows and k columns. Okay, and now we want to ask what is the product between these matrices. So we're going to define the product AB to just be the matrix which we're going to call C. And the question we could ask firstly is, what is the size of the matrix C? And this is how I always remember what the size of a product of matrices is. So A is going to be an m by n matrix, and B is an n by k matrix. And for this matrix multiplication to make sense, we need these inner indices here to be the same. And if they are the same, then we can take the product, and we can just think of these two things cancelling, and the result being an m by k matrix. So if we write C out the same way as we did with A and B, using the same notation, we will have the following. So this will be the matrix we have, and we see that we will have m rows and k columns. And the question we're going to ask is, what is the entry in this matrix Cij? So by this I just mean the entry in row I and column J. So similar to in the case of 2 by 2 matrices, if you look back at how we had each entry, we get entry Ij in matrix C, so Cij, from row I, or the ith row of A, and the jth column of B, so row J of B. So what does the row I of A look like? So the ith row of A is AI1, AI2, all the way down to AIN, and the jth column of B is B1J, B2J, all the way down to BNJ. And you see here why we need the matrices to be of certain size to take this product, because this first row here is now the same length as this column here. Both have n entries. So that's why we needed the matrices to be of certain sizes for this to make sense. Okay, so Cij is just going to come from the dot product of these two vectors. So we're going to get Cij is equal to this entry times this entry. So AI1 times B1J plus this entry times this entry. So plus AI2 times B2J, and then all the way down to the final pair of entries. So this times this. So plus AIN BNJ. And you see here that for each product, the outer indices are the same. So here we have an I, here we have a J, here we have an I, here we have a J, I, J. And all we're doing is summing over the inner indices. So 1, 1, 2, 2, all the way down to NN. So if you're familiar and comfortable with summation notation, we can write this as the sum over, and here just pick your favorite letter. I'll pick P. This is the sum from 1, so we start here at 1, and we finish at n. So it's the sum from 1 to n of A, I, P, B, P, J. And this is entry Cij of the matrix C, which was the product of A and B.